Hello everyone and welcome to my water station project. First, going over the owner's manual. Basic operations. The water station project consists of several tanks with a series of pumps and valves to transfer the water between tanks. It has several ways to sense levels in the tank by using capacitive limit switches, pressure level sensors, and an ultrasonic sensor. Control will be handled with an Allen Bradley PLC and necessary expansion cards. The physical controls will be a simple start-stop station with an E-stop, a manual auto selector switch, and momentary toggle switches for manual level adjustment. The process will be able to run from a freestanding HMI if needed. A heater located in the temperature station. The heater consists of a heating element that is wired to a separate power supply and switched on from the PLC. The temperature of the tank is monitored by a thermostat that is run through a transmitting device which sends an analog signal to the PLC. Level is controlled at one station with help from an ultrasonic sensor, and varying the speed of pump to maintain a level of water. Pressure is maintained at one station to a given set point by the use of storage tank and pressure vessel. Pressure will be measured by the analog sensor to feed the signal to the PLC. Pressure will be boosted by the station pump and controlled by a motorized valve while using a PID controller. The flow will be controlled at a station that will represent the usage of a process. Flow must be maintained at a given rate, which is with the use of a valve to control the flow of water, and a flow meter is used to measure the flow from the tank into the storage tanks. This whole process will be displayed on the HMI to show temperatures, PSI, amount of product being produced, and the current level of the tank, all being customizable through the HMI to change the process as needed for different batches. Now just going over some CAD pretty quickly. Safety relay, the high voltage components, the PLC onboard input card, the input card continued, the 32 point, and then here's the inputs. Here's the onboard output cards for my lights, onboard output card, and then there's my sensors, onboard analog card. Here's how to operate it, and all the set points and levels for it. Then going over here some troubleshooting for the cold storage, level station, and pressure station, and then going over the HMI pretty quickly here because I will be further explaining it in the video later. Here's the cold storage main display, temp station, level station, pressure station, flow station, water storage. Here's the alarm history page, going over all the different alarms, and then there's the security for the HMI. These are all my labels for my stack light on top of my cabinet, my PLC. Here's my project plan. Here's my drawings that I made for the project. Top you have the whole overview look, and then you have the tank, all the sensors, and the control boxes underneath. Here's my part list for my inputs and outputs and power supply, and then the extra stuff like that for the Ethernet control. Then here you have all my input tags. And here are all of my output tags for the program. And just a quick look at the timers that I use in the program. Now going over the bill of materials.
And the total was $21,586.69. And here's a list of my materials that I used. Now going over the CAD electrical drawings, here's my safety relay. Then into the high voltage components like the compressor, and the heater. Emergency stop. Here's my onboard input cards for my buttons, and then going over the capacitive sensors. There's my selector switches for the manual mode. If you're draining or filling. The rest of them are just free space if you want to expand it. Then going to the onboard output card. Here's my manual lights and my regular lights. All the ones in the control boxes that you'll see later. Here's a panel light. Here's my sensors. Temp transmitter for the cold storage and temperature shake, the pressure sensor, and the ultrasonic sensor. Onboard analog card. Then there's the flow meter for the high-speed counter embedded module. And then going over the rest of the outputs for the extension card, I have all my pumps and my lights and my valves. And I have my safety relay bit on the left there. Then going over my network map, all thing I have is my compact logic and my panel view connected to the SCADA switch. Here is the before picture. And here is the after, where I dyed all the water blue, made it look all clean and nice. Going over the cold storage right here. Next, you're going to see the compressor that's laying underneath the cold storage to cool the water, and here it is. Then jumping into the temp and mixing station, where we'll heat it and mix the water. And here is the level station with the filter in between the stations, with the ultrasonic sensor on top of it. Here's the pressure station with the pressure transmitter on it. And here you have the flow station with the flow meter and the motorized flow valve to regulate lower pressure. Here is the warm storage. This is my PLC cabinet with this stack light, and then you have the panel view and the e-stop on the left right there. Here is the inside of the cabinet. The PLC and then the power supply and e-stop relay, all my inputs and outputs. Here's my disconnect that I added underneath the cabinet. And then there's the inside wiring to it. And then going over the PLC program, first starting off with the system enable, where you will turn on the station. And then underneath you have all the JSRs to jump to the rest of the subroutines. Going over to the manual auto routine. And then here's my SCP routine, scalable parameters for my thermostats, and then my ultrasonic sensor and the pressure transmitter, and the motorized valve. Here's my cold storage routine for the compressor and to recirculate the water, making sure that the water is cold before it goes on to the next station. Here's my temperature station to make sure that the temperature is at its warm temp before going on to the next station, using averaging. Here is the level station routine. The pressure station routine with the PID controller to control pressure, depending on opening the motorized valve to a certain opening. And then in manual mode, it opens the valve 100%. Here is my flow station routine. At the bottom, I have math bits to show the difference between liters and gallons and mass produced for the final product made. Here's my warm storage routine. To make sure that the cold storage is full and the latchet closed if it's circulating water with the compressor. And then here are all my alarming for my HMI. Now I'm showing off the actual station itself in manual mode, and on top you have the HMI. Here is the main display where you'll see all the control box lights. I just started the system up in manual mode. Going over the cold station, you can either fill the cold station. If you drain the cold station, it fills the temp station. You can only fill or drain these to the high or low capacitive sensors on each of the tanks, or I have set points under the level station for high and low points. And on the bottom right hand corner you can see all of the lights, what they mean, in a labels form. If you have any trouble you can click into each of the displays. Then going down to the alarm history page, I'm just going to press the E-stop so you can see that alarm show up, and then the process will all stop at once. And you can see that alarm show up and start blinking in my alarm history page. Now jumping into the automatic mode, changing it from manual to auto, and then starting the system up, and the process will start. The cold storage is starting to fill up, and then once it gets to its high point, it will start circulating the water through the compressor. In the display page, you can change the set point for the temperature in the cold or the hot desired temperature in the mixing station. I'm just waiting for that cold storage to get to its right temperature, and then it'll start draining into the temp station. Now that the temp station is starting to fill up, once it gets to its high point, the mixer will turn on and the heater will turn on, and then once it gets to its desired hot temperature, it will start to drain into the level station, pressure station, flow station, and then it will start to get the final process up, and then the final product will be in the last two tanks, and then it will restart. As you can see, that mixer and the heater turns on and starts warming up the temperature in that tank. Here is the trending for that temperature station. And then here's the level. You can change the level, and then that pump goes on once I put it below the level because it's already at 200. And then that display thing on the left goes up and down. What you see here is the pressure station, and the 4.5 shows that that's the desired pressure level. The input station on that is a whole number, so you can't see the 4.5, but it is at 4.5. And now that the mixing station is done, it starts draining into the rest of the tanks. And I can change the level, so you see that level of tank go up to 220, and then it'll start to pump on again. I'm just going to put it back into 200. The pressure station, you can see it sits at 4.5 right there. Seeing around 4.4, 4.5, it just differentiates just a little bit. You can see that motorized valve opening up and closing. The flow station is recording all of the amount of liters and gallons produced. And here is a trending for that. See that bar going up and down because the level of the tank is changing, going up and down. Here's the trending for that one. And then now that the flow station is full, it will stop putting water into it, and then the pressure will drop. You'll say PID is probably out of range. Since we were changing the level station up and down, it's going to show that the alarm went off because it was out of level, because the pump wasn't running and the station wasn't on yet. In conclusion, after finishing this project, I would say all in all, it went pretty smoothly. At the start, I had to clean the stations out a couple times to get the rusty tint out of it. I love the way the blue dye in the water makes the project come together. I had to add a disconnect underneath the cabinet for safety and redesign the mixing the mixer for the temp and mixing station, along with adding a filter between the stations to clean out anything else lingering in the water from going through my project. I also added a stack plate to the top of the cabinet for extra indicators. Getting the program down for automatic mode was a bit of a struggle, and working with water can be a little frustrating, but I love the way it all turned out in the end. Learning some new programming techniques and controlling pressure pressure with the PID was a fun experience, and calibrating all the sensors was a blast. If I had to do this project again, I would put more time into PID controls for the compressor and mixing station and level station with latching and toggling with timers, and counters can get a little confusing if you don't do a good job with labeling everything. Figuring out the factory dark S-Seat was a fun ride as well, and setting up alarming and trending and making all the different displays to be able to customize the process while it's running made for some long nights, but it was all worth it in the end. I had a lot of fun with this in the project, and I hope you all like the end product as much as I do. Thank you so much for watching.